Hey guys, here's chapter 9, similar triangles. We are going to start with section 1, which is what is a ratio? And we're going to go to extended ratios and so on. So one step at a time. Quick definition of a ratio. You probably have seen this in Algebra 1, but I'm going to review real quick with a definition. So ratio is a comparison of two or more quantities. Here are 3 ways to represent a ratio. And ratios can be simplified. So, they give us an example, and we'll talk about that soon. So, think of it as like a dilation, or similar to a dilation. We can have, let's do example first, and then we'll talk about it. So, first, a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Write each ratio in simplest form. So we could use any 3 of these, any one of those, But let's use, doesn't matter. Trumpets to violins. Trumpets, we have 40. To how many violins? 24. We could also write this as 40 to 24. We could also write it as 40 colon 24. Okay? Flutes to clarinets. Change colors here. Flutes. 51 flutes. To how many clarinets? 39. Also write that as 51 over 39. Also write it as 51 to 39. All 3 of those work, okay? All right, trombones and trumpets. Trombones, 16 to trumpets, which is 40. So I'm going to take this example. We're going to write it as a fraction. Fractions are basically a ratio. So if, say, for example, I had 16 trumpets, spelled it wrong, trumpets for every, oh my God, got to get used to this new app. 16 trumpets for every 40 16 trombones for every 40 trumpets. There we go. That means every time I have 16 trumpets or trombones, I'm going to have 40 trumpets. So if I get another 16 trombones, let's write that. Another 16 trombones, I'll get another 40 trumpets. So that would be 32 to 80. First we had 16 to 40. Then we had 32 to 80. And if I get another 16 trombones, then I'll have 48 to 120. Very similar to fractions, right? So if I had 16 to 40, that's the same ratio as 32 to 80, which is also the same ratio as 48 to 120. That's what it means when we are going to write below. It can be, we wrote it already. It can be simplified because the ratio still stays the same. And that's where variables come in. So if we had something like 16 trombones for 40 trumpets, we can multiply this by any number as long as we multiply this by the same number. So say, for example, x equals 2. That would be 32 80ths. Say, for example, x was 3. That would be 48 120ths. It still works. So we can have an x here to represent any number of this fraction or ratio getting bigger or smaller. Doesn't matter. So let's write. An extended ratio can also be a comparison. It is a comparison of 3 or more quantities. Okay, we write those as this. We don't write those in any other way. Or I haven't seen them anywhere. They probably can be written other ways. So, for example, number 5, the ratio of 2 complementary angles, 3 to 7, find the measures of both angles. Okay, so first we have to know what are complementary angles. Complementary angles are 2 angles that add to Is it 90 or 100? 90 or 180? It's 90. So we have two angles that add to 90 degrees, and they have a ratio of 3 to 7. So remember, we can write this as 3x to 7x, because we know the ratio is 3 to 7. So it could be, if x was 2, it could be 6 to 14, right? If x was 3, it could be 9 to 21. Which one of these adds to 180 degrees? Because they all work. If x was 1, that would be an angle of 3 degrees and an angle of 7 degrees. We could also have an angle of 6 degrees and 14 degrees. We could also have an angle of 9 and 21. We could also have an angle of 12 and 28, or 15 and 35, or 18 and 38, or 21. Ooh, sorry, not 28. 35 is correct. 18 and 42, or 21 and 49. Are we getting close? We can go to 24 and 56. Ooh, 56. 70, 80, close. What about 27 and 63? There we go. So there is our guy. It could have been 27, 63. That is the long way. That's the guess and check way. There's an easier way. We could just do this. We know it's got to be 3x plus 7x equals 90. We don't know what x is, but we can solve now. So we get 10x equals 90. X equals 9. So let's check. We went 1, 2, 3, 4, 5, 6, 7, 8. 8 away from 1. Yeah, so x is 9. This was when, sorry, I did it wrong. This would be x is 1, right? Because then it would be 3, 7. So 2, 3, 4, 5, 6, 7, 8, 9. There we go. When x is 9, so if we plugged in x here, that'd be 3 times 9, which is 27, and 7 times 9, which is 63. There we go. Make sense? Okay, so number 6, very similar. We could just start with 4, 1, 4x, 1x, and then we get, if x is 1, 4, 1. If x is 2, what would that be? Still 8, 1. Ooh. Or would it be 8, 2? No. Be 8, 2. Remember, fractions, we can reduce those. 3, 12, 3. 16, 4. All the way up to 180 degrees. That would take a long, long time. So let's not do that, huh? Let's do it the shortcut way. We know we have 4x plus 1x, and that's going to equal 180 degrees because we have two supplementary angles that add to 180. So that's 4x plus 1x. That gives us 5x equals 180. X equals 36. Ooh, we would have done it 36 times. That's way too much time. So let's now solve. X is 36. So we get 4x equals 4 times 36, which equals 144. And x equals 36. So our ratio is going to be 144 degrees to 36 degrees. There we go. Pretty cool. All right, 7 and 8. Let's do it. The ratio of the measures of the angles in a triangle. So we know we have any ratio like this. X could be 1, X could be 2, X could be 3, X could be 4. Doesn't matter. Find the measures of the angles. So if X was 1, it would be 4, 7, 9. If X was 2, we would get 8, 14, 18. If X was 3, we get 12, 21, 27. We need to find the measures of the angles. So all these have to add to 180. We could keep going and figure it out that way. It just seems like it's too much time to do that. So we can do it the algebraic way. And that's why algebra is so nice. So we get 16, 20x equals 180. X equals 9. So now we plug back in. So 4 times 9, 36. 7 times 9, 63. And 9 times 9 equals 81. So our ratio would be 36, 63, 81. Boom. Now 8, 8, same thing. And then we have to find the angle of the largest angle, which isn't too bad. You guys could do that. So 9 and 10, the ratio that measures the sides of a triangle, let's just do the 9. If the perimeter of the triangle is 76, okay. Find the length of each side. So the sides of the triangle have this ratio. So for example, if it was 2, 8, 9, if we did a dilation for 16, 18, they would be similar. They would be similar triangles. We're going to get to that later. But in this case, the ratio would be the same. So we could also get a bigger triangle. 6, 24, 27. We need the outside here to add 276. We could keep going, or we could do the shortcut. 2x plus 8x plus 9x equals 76. 19x equals 76. X equals 4. So if x equals 4, we had 2x, 8x, 9x. So we plug in 2 times 4. Oh, we only need to do one more. Oh well. So that might have been easier to do guess and check. 8 times 4, 9 times 4. So we get 8, 32, 36. So 8, not degrees now. Whoops. 8 to 8 inches. Oh, it gives us 8 inches. So we'll just write 32 inches, 36 inches. There we go. All right, so on to the next. So what is a proportion? A proportion is, let's get a different color, is an equation that states two ratios are equal. So a portion is written in a fraction form. So if you have a over b, it's going to equal c over d. So we did that. So if 1 over 2 equals 2 over 4, we know that to be true. So we can solve by cross multiplying to show that's true. So what we do is we multiply 2 and 2, multiply 1 and 4, see if it equals. Times 4, does that equal 2 times 2? It does. The reason that works, I'm going to show up here, is say, for example, I had, let's do number 11. 4 over x equals 2 over, I'll just do it for number 11. So say I had 4 over x equals 2 over 7. If I multiplied both sides by 7, so if you do it to one side, you got to do it to the other. Remember, equation is like a scale. Then what happens is the 7s cancel out, and you're left with 28 over x equals 2. And then you have to multiply both sides by x. That gets rid of the x, and we get 28 equals 2x. So that is where cross multiplication comes from. So remember that 28 equals 2x. So here we go. So if I would have just cross multiplied, do hot pink, cross multiply, I get 4 times 7. 4 times 7 equals 2 times x. There's our 28 equals 2x. So that's where cross multiply comes from. If you didn't know that, cross multiplication will be confusing once you get to higher math. But if you do know that, cross multiplication is a nice shortcut. So I do that all the time because it's a nice shortcut. It's quicker. So here we go. Let's do the odds here. Number 11, cross multiply. we get x minus 1 times 19 equals 13 times 6. This gives us 19 times x, 19 times negative 1, 19x minus 19 equals 13 times 6, which is 78. We get 19x equals 78 plus 19, which is 97. Divide by 19, x equals 5.1. Okay, number 15, same thing, cross multiply. 20 times, always forget, don't forget your parentheses, it's important, and then 10 times 9. So it's important for when you distribute. So you get 40x minus 180 equals 90. So we get 40x equals 270, x equals 6.75. So what that means, let's go back to number 11 real quick. So we found x to be 14. So let's plug it in and see what that means. We get 4 over 14 equals 2 over 7. Is that true based on our knowledge of fractions? It is, and that's where this idea comes from, okay? So if we plugged it back in, we would get, let's try number 10. 10 over 6.75 times 2 would be 13.5 minus 9. 13.5 minus 9 would be 4.5. 4.5. Does that equal 20 over 9? It does. If we double this, multiply by 2, gives us 29. So if we had 10x and 4.5x, if we did it to the second, if x equals 2, then it would be equal. Okay? Number 7 and number 17, number 19, same idea. Cross multiply. Let's make this a little bit, ooh, nice. So we get 18 times x minus 20 equals 3 times x minus 11. Doink, doink. 18x minus 360. 3x minus 33. Let's get the x's on one side. 15x. Add the 360 to 33. That's 327. So x is going to be equal to 21.8. You can always plug it back in and check. Since it's asking to solve each proportion, yep, we're just solving for x. 19, same thing. This is going to be a quadratic one. Here we go. 5 times 27 equals x minus 1 times x plus 5. We are trained for this. So we get 135 equals x squared plus 5x minus x minus 5. 135 equals x squared plus 4x minus 5. And then in order to solve, we got to get everything equal to 0. So 0 equals x squared plus 4x minus 140. Oh boy, so we have to find 2 where it equals to 0. So we have our x's, we know that. We know one has to be plus, one has to be minus, and they need to be close together because we need, say this is A, this is B. We need A, B, when they're multiplied to give us negative 140, and we need them to add together to give us 4. So if we could try on error, they need to be close together. So 10 and 14. Oh yeah, that should be it. So which one's going to be plus, which one's going to be minus is determined by the middle one. Is it plus 4x or minus? So since it's plus, we know that the 14 has to be plus. So this is going to be 14. This is going to be 10. So we set each equal to 0. So we get x plus 14. Let's do it below it. X plus 14 equals 0, and x minus 10 equals 0. So x equals 10, and x equals negative 14. We have 2 solutions. Nice. There we go. So that is 9-1. If you have any questions tomorrow,